Hello friends, welcome to my YouTube channel. My name is Saurabh Chhabra. I would be discussing today about Azure load balancers. So if you find this video useful, please subscribe to my YouTube channel and like and share. And you can send in your queries at the comment, and I'll try to respond. So let's just get started. Let's discuss about Azure load balancers first. What exactly is Azure load balancers? So there are different types of load balancing solutions which Azure provides at the different layers, right? So we have application layer, we have networking layer, we have a traffic which is HTTP, HTTPS, and there's different kind of traffic where different ports are there, and applications are listening at the different ports. So we need that kind of load balancing solution. There are databases which require load balances. I mean database servers which are behind the load balancers, and we need only the port 1433. So there are different type of load balancers, right? So Azure provides different solutions for load balancing, right? So we have application gateway for applications. We have front door for HTTP traffic. At the global level, we have normal load balancers for different applications, which can be, at IAS level, and we have the traffic manager, which is kind of a global load balancer and works at the DNS level, right? So let's just get started about the application gateway first. So what exactly is application gateway and how it works? So application gateway is it's a layer. I mean, usually it's called as a layer 7, but it also works at layer 4, uh, and at layer 4, OSI stack. So when we say application gateway, so what exactly application gateway does? It basically is used as kind of a load balancing solution where we have different backend pool, and that can be behind application gateway, and application gateway provides different a solution where it provides WAF capability. And if we enable WAF, web application firewall, it provides us filtering around those firewall, and then we can use those web application firewall to enable rules, and allow traffic which we want, and disallow, and disallow the content and the traffic which we don't want that to happen. So it has the WAF capability at the application gateway. The other thing that it provides is the cookie-based affinity, session affinity, where it usually keeps your session alive, and when if you come back at a desirable time, it opens up the same session, right? So it also gives us the capability of SSL offload. It provides an end-to-end SSL. So these are the two things where you as an application owner can decide if you want the SSL to be offloaded at the application gateway level, and you don't want traffic to be encrypted and going to your VM, right? So if you want that to happen, you can offload the SSL at the application gateway layer itself, and you can transfer your traffic at the port 80, or whatever port you want at the VM level. And if you always want an end-to-end SSL, you can definitely provide the certificate at the application gateway, and it'll encrypt the traffic itself, and the traffic would be end-to-end SSL. The other thing that it provide is URL-based routing. So when we say URL-based routing, it means that if, for example, if we have a URL which says contesto.com, and then we have sub pages which it says contesto.com/images. So we want that traffic to go to a particular set of VMs, and if we have a slash video, that kind of traffic would go to a particular set of VMs. So this can be uh, done enable in terms of application gateway, and that can be done in terms of we can have different backend pools, and then you can have the URL based redirection to be able to route the traffic accordingly. So let me just give you a scenario where I would be showing you the diagram, right? I would be showing you the architecture diagram where how the users are trying to access. So there are two types of users. One is at the internal users, which are the on-prem users, and the other is the from the internet, right? So both of the capabilities are there. So if you have an internal users, it usually travel and connect to a private IP, which can be part of the front end IP in application gateway. And if users which are coming from the outside can be added as a public IP, right? It would be a public facing URL. So you can have a similar URL, or you can have different URLs for this kind of traffic to work, and both can be added inside an application gateway. You can use application gateway as a shared one as well. You can have multiple URLs being defined at the application gateway level. What we can do is we can create listeners, and then every listener have different URL, and and that listener can have different backend pools, right? And we configure what we call rules out of it. And what rules does is basically redirects your traffic, which is part of the listener, and it's redirect your traffic to a particular, if there's one VM or a VM scale set, or we're talking about an external or on-prem servers. If the backend pool can also be an Azure app service, so these are the backend pool, can be part of it. So rules are basically assigned to it, so the traffic would travel accordingly. And the other thing that I want to show you is the firewall configuration here, right? So firewall configuration is where we enable the WAF capability of application gateway, and accordingly it basically allow us to filter out the traffic, and you can say what is allow, what is not allow as per the standard. So Microsoft is has done its background, and what it does is it basically give us the common blocks the common the common bugs, right? So it is already blocked at the WAF level, right? So this is how basically the application gateway works. So let's just talk about the other solution, which is Azure Front Door. Azure Front Door is basically kind of a global solution for load balancing. It also works at HTTPS traffic. Basically, it works at the global level. And when I say global level, when we talk about application gateway, you usually create an application gateway, and it is assigned to a resource group, and it basically is created at a region level. But when we are creating Azure Front Door, it is a global resource. It is not giving an option to create an application gateway inside a particular region. So whenever we create an application gateway, it's kind of a service which have managed Azure Front Door at edge locations. And whenever we route the traffic, it allows us to route it according to the region specific. So if a user which resides in India wants to talk to a URL, right? It goes to front door, and the front door, we have different backend pools. A backend pool can be in Brazil South, a backend pool can be in India, right? So what Azure Front Door does is it basically allows you to go to your nearest nearest failback nearest failback region. So if you're going from India, then it will go to India application gateway. If you're going from Brazil South, it will go to the Brazil South application gateway. And when I say application gateway, we understand that the solution is in such a way that the URL is redirecting your traffic to Azure Front Door. Azure Front Door is redirecting your traffic to application gateway, and in the end, your application gateway is redirecting your traffic again to the backend pool, which can be app service or a VM or a VM skill set, right? So this is how Azure Front Door works. So let's just discuss about. I want to show you the architecture diagram as well. So this is how it works. So I've already told you about the user case where we have HTTPS traffic and we have two geographical locations. Azure Front Door service is basically redirect the traffic according to your location. You can have path based routing as well. And again, upmost important thing that it usually provides is the static content caching, which is not in the application gateway. So we, if you want a static content caching, that is where the Azure front door comes into picture, where you have a static content where it gives you a caching capability, and it is kind of a very fast solution where it is have a good performance and a lowest latency for any HTTPS traffic to come across. So let's just talk about a normal load balancer. When as normal load balancer, it can be of two types, right? External and internal load balancers. So load balancer, Azure load balancer is basically an inbound and outbound traffic which is coming, and it is aligned where it has a backend pool. Backend pool can be of VM or a VM scale set, and it basically, it has different rules, and assign those rules. It basically redirects your traffic accordingly. So so what we usually have when we say public load balancer and internal load balancer. So public load balancer is external load balancer which have a public IP assigned to it, and an internal load balancer is the load balancer which have an internal facing load balancer which have a private IP assigned to it. So this is how we differentiate between the load balancers. So let me just show you what exactly how we are configuring and what kind of things we need to do. So if you see traffic which is coming from the source, we need the source IP to configure the load balancer. We need the destination IP where the traffic would be going. We need the source port at which level the port wants to talk to. We need we need a destination port as well, and this is how the traffic would be would be moving. And we, of course, we need the protocol, right? So it works at the TCP and UDP level. So the other thing I wanted to discuss was the NAT feature at the load balancer. So if in any case you want a specific kind of a routing which you want, so it has this capability where the traffic would flow to a particular VM where you have defined the NATing at a particular port level, right? So that can also be done at the load balancer level. So the other thing, the other load balancing solution is of course the last one, which is the traffic manager. Traffic manager is again the load balancer at the global level, which allows you to control the how the traffic is distributed across your application endpoints, and it is again the internet facing endpoints. The only two key benefits for Azure Traffic Manager is the traffic routing methods, right? So it basically have a priority based routing method, a weightage, performance, geographic, multi-valued, and subnet. So if so, these are the things where we can define the routing, right? And we can have monitoring setup at the endpoint health, and you can always have an automatic failover done, right? So this is how basically the traffic manager works. It works at the DNS level, and whenever the URL comes, I mean, it basically redirects at the DNS at a particular endpoint. So let me just discuss about the scenario, right? Where if you can see the diagram, I've shown you two different regions, which is one is East US, and the other is West Europe. If you can see here, the other is West Europe. So the other okay. Go back. Yeah. So if you can see this diagram, we have two external load balancer, which is behind the traffic manager, and traffic manager is active passive. So one region is down at the moment, and the other region is up. So all the traffic would be going through that, and it is having the health probe done, right? So if this comes down, it automatically have the West Europe up, and the traffic would be following, flowing that, and it can be active as well, where we have the priority done, and all the traffic would be going to one, and that is the priority is, and if we have the weightage as well, performance. So these are how the the traffic manager decide how to route the traffic, right? In this particular scenario, we have an external load balancer, and behind that we have web tire. Behind this we have two VMs which are behind the internal load balancer, and you can see these are the external load balancer which will have a public facing IP, and this is the internal load balancer which will have a private IP, and behind that we have databases which are again behind the internal load balancer. So this is the basic architecture where it is showing for a traffic manager. So let me talk to you about the use cases. So you can use this as kind of a cheat sheet where you can decide what and what solution to opt for, right? So different. Let me just show you. So this is how we usually decide on. You can take a screenshot of this particular slide, and you can read it later again, right? So you can refer this while you are working. So when we say an https traffic, we first of all know what kind of traffic it is. So if it is not an http or https, we immediately will think about a load balancer, right? We'll not think about an application gateway, right? So now the next question would be, will it be an internet facing application or no? If it is not an internet facing application, you can simply have a simple load balancer, right? Where you can have internal load balancer, external load balancer, but it is not internet facing. So you can simply have a load balancer. But if it is a internet facing, you can deploy a traffic manager ahead of a load balancer. So the other thing where you have an HTTP, HTTPS traffic, right? So we ask, will it be an internet facing application? In both the case, yes or no, you would be going with the application gateway, right? But the other thing is, do we require a front door out of in front of it? So if it is an internet facing application, we do require a front door. But if it is not an internet facing application, we do not require a front door. And when we say an internet facing application, it depends upon the global and local level. We can work on a local level with an application gateway without an firewall, right? So you can see there is no FAF enabled firewall in an app, in a region in a normal load balancer. So now what we do is we enable the WAF capabilities. But the other thing is that if it is of multiple location, then we need Azure front door. So this is the use cases where uh, we decide upon what level of load balancing solution we would provide to the customer. So that would be it. So if you have any questions, do write to me, or you can email me as well. And thank you very much. And please like to my channel and do subscribe. Thank you. I would be creating few more videos out of the load balancing solution, where I would be going to deep dive, and I would be showing you how it is configured, and the solutions out of it, and I will be creating a few videos out of the load balancing solution. Okay, thank you very much. Thank you.